Hello, I'm Mike McCormack of AIQ, and this video clip is to introduce the Insight S700, and it describes the product's potential to deliver enhanced safety, reliability and efficiency to the distribution network. And just a brief recap of AIQ. It is the outcome of a collaboration between leading engineers in the European power industry, and the Insight range of products and software is the result of this collaboration. The solutions we deliver have been designed to enhance the networks in the face of major changes, with, for example, the onset of distributed generation. As part of the design process, AIQ has developed high earth fault sensitivity of better than 10 kiloohms, supported by synchronized data of better than 1 microsecond resolution, all packaged in robust and reliable product designs. Our technologies deliver the major enhancements needed to address the safety, reliability and efficiency of the network with a focus on improved safety. Insight S700 is a high impedance earth fault protection relay installed in the distribution network's primary substation, one for each outgoing feeder. It can be set up in monitoring mode to detect earth faults including high impedance and notify the user of its occurrence. And it can also be set up in tripping mode to operate the circuit breakers to clear both earth faults and phase faults on the feeder. It detects high resistance earth faults in excess of 10 kiloohms, works with all types of neutral treatment, and exploits novel and multiple established algorithms operating simultaneously, and is readily retrofittable to enhance or to replace existing earth fault and feeder protection. It has 8 analog input channels sampling at 128 samples per cycle, optional external clip-on CTs for non-intrusive installation, with core balanced CT connection for extra sensitivity, digital IOs for status monitoring, alarms and for CB operation, with 2 Ethernet communications channels, one to server, one to SCADA, iRig-B time synchronization, with optional antennas for GPS clock and 4G, 5G communications. So now we'll take a look at the fault detection algorithms. S700 has a range of traditional and novel fault detection algorithms for different applications and different neutral treatments. Novel earth fault detection algorithms consist of transient reactive power TRP and waveform similarity coefficient WSC. The TRP captures the fault-initiated transients to detect earth faults in networks with isolated neutral and compensated neutral treatment. The WSC uses a cosine similarity algorithm to recognize the waveform of the high impedance earth fault and is applicable to a network with all types of neutral treatment. There are a range of traditional earth fault detection algorithms together with broken conductor detection and phase fault detection. They are based on the fundamental frequency, magnitude and phase calculations and are selectable based on different neutral treatments and the S700's mode of operation, as explained in the following slides. For networks with an isolated neutral, TRP, WSC, zero sequence over voltage, zero sequence admittance, Y0 and delta Y0 can be applied. The earth fault current for systems with isolated neutral is characterized by its strong reactive component. Therefore, I0 sin phi is a traditional technique and is available. Lastly, the open conductor based on the ratio of I2 over I1 is universally applicable for all networks. If S700 is deployed for operating the circuit breaker, phase fault detection algorithms including phase overcurrent, delta overcurrent and delta admittance can all be applied to operate the circuit breaker for phase faults. Systems with isolated neutral allows transient earth faults to be self-extinguished. Tripping can be arranged for permanent earth faults. Lastly, auto reclose scheme is available to restore power after tripping if the fault is found to be transient in nature. Fault detection algorithms for systems with compensated neutral is similar to those with isolated neutral, except I0 cos phi now replaces I0 sin phi because of the strong active component of the earth fault current. The S700 in tripping mode for systems with compensated neutral is again similar to systems with isolated neutral, with I0 cos phi replacing I0 sin phi. Again, transient earth faults can be self-extinguished, but for permanent earth faults, tripping is available. For systems with resistance earth or directly earth neutral, earth fault currents will normally be sufficiently high to cause traditional protection operation. However, if high impedance earth fault is specifically targeted to be identified and not for tripping, the S700 can be deployed in monitoring mode to detect such faults. If S700 is deployed for tripping in resistance earth networks, phase fault detection algorithms such as phase overcurrent can be enabled. Again, auto reclose scheme is available to restore power after tripping if the fault is found to be transient in nature. Instead of standalone operation, S700 is also deployed as part of the Inside M700 transient fault localization system as a station node. This is covered in a separate video on the M700. Similarly, S700 is deployed as part of the Inside L700 fault localization system. This system will be deployed at each outgoing feeder and form a substation node of each feeder. This is covered under a separate video on the L700 system. Thank you for visiting our website, and if any of the AIQ team can help you with any questions that you may have, please do not hesitate to contact us.